So last time in class we took notes over the vocabulary for angle pairs, and now we're going to finish those notes. So to follow along with this video, you need to take the angle pair notes back out and then complete the notes as I go through the video. Before I do that, I want to just quickly review some of the vocabulary from last time so it's familiar again before we take the notes. So adjacent angles, we said, were two angles that are next to each other. They don't overlap, they just share a side. And adjacent angles help us describe other words like linear pair. So linear pair shared a side, okay, but they also, right here, form a line. So if they share this side and form a line, then they are going to be a linear pair. Okay. We also have complementary angles. Complementary angles were two angles that added to 90 degrees. So they could either be adjacent like this picture and touching, or non-adjacent like this picture and not touching. Then supplementary angles, they added to 180. And we talked about last time how linear pairs are always supplementary. But over here, just because they add to 180 does not mean they're a linear pair. This right here is a linear pair. Okay? This example is a linear pair because they share this side, and then the side they don't share forms a line. Over here, on the other side, this is not a linear pair. Okay? It's not a linear pair because they don't have a side that's touching each other. They're not next to each other, and they don't form a line. So when you have a linear pair, it'll always be supplementary, but just because it's supplementary doesn't mean it's a linear pair. Okay, and then finally we had vertical angles. The vertical angles were the ones that were across from each other. So these two are vertical, and these two are vertical, and vertical angles are congruent. All right, now that we've had that quick review, let's see if we can practice it a little bit. Now in this first section, we're going to look at these four separate pictures. And for these four separate pictures, you're going to use one of these three terms: linear pair, vertical angles, or adjacent. You may use one word or you may use all of them. Just depends on the picture. Okay? Or two words. But we're only using those terms. Okay, so on the first picture, those angles are across from each other. And when the angles are across from each other, those are called vertical angles. Vertical angles don't share a side, so they can't be adjacent, and because they're not adjacent, they don't form a line, they're not a linear pair. Okay. Example number 2. These angles, they share a side and they form a line. That makes them a linear pair. Because they share this side, they are also adjacent. All right. Example 3. Example 3, if we're looking at that, well, they share a side, so that makes them adjacent, but they don't form a line, so they are not a linear pair. They are also not across from each other like example 1, so they are not vertical. Last but not least, example 4, these angles share a side, that makes them adjacent, and they form a line, that makes them a linear pair. So these angles are both adjacent and a linear pair. So anytime you have a linear pair, the angles will be adjacent, and because they form a line, which is a straight angle, you know they're supplementary. They add to 180. Okay. Example 1, we need to name 3 angles that are adjacent to, that means share a side with angle ABC. So let's find angle ABC. So I'm going to trace it. ABC is this one. So if they share a side, we got a couple of options. Like this option, we could try saying angle CBD because that shares ray BC, right? So angle CBD would be an option. Or we could be adjacent on the other side, so we can have ABH maybe. ABH is adjacent because it shares the side AB. But I said to do 3, and that's only 2. So let's look at some other options, and there are definitely lots more than 3 options. As long as they share a side, it's okay. So what if they shared side BC and then they had E? Or they could have CB and F, or CB and G. On the other side, they could have ABH, or ABG, or ABF. It just keeps going. We'll just write down the one I've highlighted in pink, but there's lots of correct options. Now remember, when you name the angles, this vertex, which is B, has to go in the middle. Okay, example 2, which I don't have on the screen, you need to identify whether the angles are vertical angles or a linear pair. So take a quick second, pause the video, write down your answers, then we'll check them. Okay, 1 and 3 are vertical because they're opposite. 2 and 3 share a side and form a line, they're a linear pair. 4 and 1 are a linear pair, and 2 and 4 are vertical. Okay, let's look at example 3. When we have two lines that intersect, we have 4 angles. And I gave you one of the angles is 113, and you need to find angles 1, 2, and 3. And when you have this problem, one of the angles is going to be really easy to find right away, and that angle is 2. It's 118 degrees, and we know that because angle 2 and this angle are vertical, so they're equal. But now we got to find the other ones. Well, if we take 1 and 2, for example, they share a side and form a line, so they're a linear pair. So 1 and 2 are going to add to 180. So if I do 180 minus 118, that will give me 62, and that is the measure of angle 1. And so because 1 and 3 are vertical, 3 has to be 62 as well. So every time you have two lines that intersect, you're going to have 4 angles. The opposite will be equal. The ones that share a side will add to 180. All right, let's look at example 4. Well, let's figure out what type of angles these are. Well, these angles are opposite each other. When they're opposite each other, they're called vertical, which means they're congruent. So that means that 6x minus 12 has got to equal 4x plus 20. So to solve, I'm going to subtract 4x and get 2x, add 12 and get 32. So when I solve, x is 16. Now this one only wanted you to find x, so we can just stop. But x is not the measure of any of the angles. So if it wanted the angles, you take that value and plug it in. Let's look at example 5. Example 5 wants to find x as well. These two angles, they share a side and form a line. That makes them a linear pair. And if they're a linear pair, that means they add to, hope you're thinking it out loud, 180. Okay, let's just combine terms in our head. X and 3x would be 4x. 28 and 12 would be 40, all equaling 180. So now I'm going to subtract 40, and I get 4x equals 140. I'll divide by 4, and x is 35. Okay, again, we're just finding the variable. Now this one, it changes because I want x and I want the measure of angle 1. So let's start what I know about x. I've got two angles that have x in them. They're opposite from one another, so they're vertical, so that means they're equal. So that means 4x minus 18 equals x plus 24. So to solve, I'm going to subtract x from both sides and get 3x, add 18 to both sides, and get 42. And then I'll divide by 3, and x is 14. Now remember, this is the value of the variable. It's not the measure of any of the angles. So to get the measure of the angles, I'm going to have to plug it in. These angles are the same. I can plug it in either way. I'm going to plug it in over here because it looks simple. So 14 plus 24 is going to give me 38. But that is not the measure of angle 1. To get the measure of angle 1, I know that these two are a linear pair, so they add to 180. So I'm going to do 180 minus 38, which is going to give me 142. And that is the measure of angle 1. All right, let's try another example. Example 7. Now we need to find x and y. So I can look at it and say, well, these two are a linear pair. They add to 180, but I can't solve an equation with x and y. So I don't want to do that. But I do know that these two angles here both have x in them, so they've got to be equal. So, because they're vertical. So I can find x by saying 6x minus 12 equals 4x plus 20. So I'll subtract 4x and get 2x, add 12 and get 32, so that means x is 16. But now it wants us to find y. So I can't say anything equal to 16. That's the measure of the value of the variable, not the measure of the angle. So I'm going to have to plug in 16 somewhere. So why don't I do it here? That's 4 times 16 plus 20. So that's 64 plus 20, which is 84. So I now know that these two angles are 84, but that still doesn't give me what the angle that has y in it is. But I know that I've got a linear pair. So if I do 180 minus 84, I'm going to get 96. So I know this angle here has to be 96. So to solve, I'm going to do 3y equals 96. So I get y equals 32. Okay, I want you to do example 8 on your own. Look at example 8 and see which two angles have x in them. Then decide if they're vertical or a linear pair. That will allow you to find x, and then you can plug it in to find y. Pause the video and do example 8 on your own. Okay, so I've done example 8 for you. Now the first thing I did was I saw that these two angles, because they shared a side and form a line, these were a linear pair. So that is why I wrote this equation. 5x plus 35 equals 180. I combined like terms in my head. Got x is 29. Then I needed to figure out what y is. Well, I could plug it into either angle, but I recognized that these two angles here are vertical angles, which means they're equal. So I decided it'd be best to plug it into the 3x plus 10, and that gave me that this angle here was 97. And once I knew that, I knew y plus 40 had to be 97, so then I could solve and get y is 57. All right, almost done. 2 more problems. Example 9. Example 9 does complementary, and then 10 also does supplementary. Complementary angles, if you remember, are two angles that add to 90. So it says that A is complementary to B, so that means A and B are going to add to 90. So to write my equation, I know these two add to 90. So let's just, combine like terms in our head. 2 and 4 is 6x. 24 and 12 is 36 equals 90. So I'm going to subtract 36 from both sides. So I get 6x equals 54. I divide, and I get x equals 9. But it wanted to find x in both of the angles. So now I'm going to take that 9 and plug it in. So I have 2 times 9 plus 24. So that's 18 plus 24, which is 42 degrees. Now for angle B, I can do the same thing. I can take x and plug it in here. Or, because I know they're complementary, that means they add to 90, I could also do 90 minus 42, which gives me 48 for angle B. All right, last problem. Now these problems seem to throw people not because they're really hard, but because they give you too much information to find x. We need all the information eventually, but not right at the start. So let's see what it says. It says A is supplementary to B. Well, supplementary means they add to 180. And it says that A is complementary to C. Well, complementary means they're going to add to 90. So let's write that out. That means that A plus B will equal 180. And means that A plus C will equal 90. You can use either one of those facts to figure out what x is. So it doesn't really matter. I'm going to use this one. So if I add A and B, that gives me 13x plus 11 equals 180. So I'll subtract 11, and I get 169, and I divide and get 13. Now that I've got that, now I need to plug it in. So the measure of angle A is going to be 13 plus 10, which is 23 degrees. The measure of angle B is 12 times 13 plus 1. Well, 12 times 13 is 56, plus 1 is, 157. And then the measure of angle C is 5 times 13 plus 2. Well, 5 times 13 is 65, plus 2 is 67. Now, notice this. Over here we said A and B should add to 180. Well, look. Oh, they add to 180. We said A and C should add to 90. Well, look, these add to 90, so we did it correctly. Your homework is to take the worksheet that was due today that had midpoints with fractions on the back, and you need to do the front of the worksheet that deals with angle pairs. That is due at the start of class next time, and then we will continue on from there.